Hey there! Functional programming has been around for a while, but lately, with growing popularity of languages like Rust and even Microsoft exploring built-in support for functional types in C#, it's quite obvious that people are really into this approach, and there is a good reason for that. Before we explore whether functional programming suits Unity, let's quickly cover what it is. While it includes many concepts like pure functions, immutable data and composition, in this video I will focus on one of its most impactful ideas: result types. Result types are a way to handle errors in a functional manner. Instead of throwing exceptions, we return a value that can be either a success or a failure. Let's take a look at how a simplified result type can be implemented. Of course, to make it really useful and avoid a lot of repetitive code, we need to improve it and add more methods. So, for the next examples, I will use a more complete implementation that also supports unitasks for safe use of async await syntax. You can find it in my repository, which is linked in the description. Alright, let's create a simple function that returns a result like so. What's awesome about this is that it makes it super clear whether a function can fail or not, and what kind of error you might get. No more guessing whether you need to wrap anything in a try-catch block or check for errors. However, the true power of result types comes when we chain them together, for example with extension methods. Some more common ones are map, bind, and tap. If you are new to these methods, give them a try and see if you can figure out what this chain might be doing. All of these methods return a result type, while potentially transforming it in different ways. Map takes a function that transforms the awk value and then returns a new result containing the transformed value. If the calling result is an error, it simply returns a new result with the same error value. Bind is similar to map, but it takes a function that transforms the awk value directly into a new result type. Tap is used to perform side effects without affecting the result. In this example, we log the result of the preceding calculations if they are successful. There are also mirrored versions of these methods, designed for error handling. The final thing to mention in this introduction is how the syntax allows you to use async await effortlessly. With additional overloads for the extension methods, you can apply nearly the same syntax for both synchronous and asynchronous methods, as well as any combination of the two. Now, let's return to our main question: is it suitable for Unity? The answer is definitely yes, but mainly for some specific scenarios rather than an entire project. In performance-critical situations, such as extensive loops, the overhead can become a concern. One great use case is in communicating with web APIs. Why? Because the chaining syntax works beautifully for managing the multi-frame operations of sending requests, getting responses, processing data, and handling any errors which might occur. So now, let's dive into the deep waters and see how we can implement such a system. The first thing to keep in mind is that we carry the errors through the entire chain to handle them if they occur. This means we need a way to manage them at the end. So, how about having a service that can capture an error and display it to the user? Another thing to consider is that errors might have various levels, which we might want to handle differently. Personally, I like to use the following ones. Retryable, an error that can be fixed by retrying the operation, for example, a temporary network issue. Rewritable, an error that can be fixed by changing the input, for example, when a username is already taken. Fatal, an error that cannot be fixed and requires a restart of the game. For example, a conflict in the game state. Apart from the error level, it's important to provide a meaningful message for the user, so the final error type can look like this. Now, let's create a service to handle the errors. It should display a pop-up with a message and a button to continue. Wait for user interaction. Return true if the operation can proceed, either by being ignored or retried, or return false indicating that the operation should be cancelled due to the ongoing restart of the application. For the final part, let's see how we can use this system in a real-world example. Let's assume that this method is called when the user clicks the rename button in the game. It uses the character service, which returns a result type, to rename the character. If the operation fails, the error is passed to the error service. If the error is fatal, the operation is cancelled, as the game will restart. If the error is not fatal, the user can choose to retry the operation or ignore it. If the operation is successful, the game continues. On the other hand, the method from the character service may look like this. In this example, both the authentication service and the backend service also return result types, allowing us to chain the calls together and handle any potential errors at the end. And that's it. What do you think? Is it cool? I hope you enjoyed the video and learned something new. If you have any questions, feel free to ask them in the comments below. And if you want to see more content like this, don't forget to leave a like and subscribe. Also, if you are interested in making your work with Unity even smoother, check out my series on AlchemyBow.core, a simple yet powerful framework that can help you make your architecture shine. Thanks for watching and see you in the next one.